Imagine a place at the edge of cosmic understanding, a place where the very fabric of reality is pushed to its absolute limit, a place where time gets shredded and space gets warped beyond recognition. This is a black hole. So, what would happen if you fell into one? The journey would be the most extraordinary and final trip you could ever take. Your first encounter with the black hole's immense power would be a process with a rather playful name for a terrifying reality: spaghettification. This isn't just a quirky term, it's a literal description of what gravity would do to you. As you fall feet first, the gravitational pull on your feet would be exponentially stronger than the pull on your head. This difference in force, known as a tidal force, would stretch your body, longer and thinner. You'd be drawn out into a thin stream of atoms, a human noodle stretched across kilometers of space before being pulled into the abyss. It's a strange and unsettling thought, but it's just the beginning of your cosmic ordeal. Next, you would approach the most famous feature of a black hole, the event horizon. This isn't a physical surface you could touch, it's a boundary in space-time, a point of no return. To escape a planet's gravity, you need to travel at a certain escape velocity. For Earth, that's about 11 kilometers per second. But at the event horizon of a black hole, the escape velocity exceeds the speed of light. Since nothing in the universe can travel faster than light, once you cross this threshold, escape becomes physically impossible. There are no dramatic U-turns, no last-minute reprieves. Every path now leads in only one direction, inward. Inside the event horizon, the laws of physics as we know them begin to unravel in the most profound way. Here, Einstein's theory of general relativity predicts that space and time actually swap roles. On the outside, you can move freely through space, forward, backward, left, right, but you are always forced to move forward in time. Inside the black hole, space becomes time-like. You can no longer control your movement through space. You are inexorably pulled toward the center, just as you are always pulled toward the future. Meanwhile, time becomes space-like. It's a concept that bends the mind, but it means all paths, all possible futures, end at a single point in space, the singularity. Now, your experience would depend heavily on the size of the black hole. If you fell into a smaller, stellar mass black hole, one just a few times the mass of our sun, the tidal forces would be extreme. You'd be spaghettified long before you even reach the event horizon. But for a supermassive black hole, millions or billions of times the sun's mass, the story is different. Its sheer size means the gravitational gradient is much gentler. You could cross the event horizon completely intact, unaware for a few moments that you've passed the point of no return. You might even have time for one last thought. But here's another twist from relativity. What happens to you and what an outside observer sees are two very different things. From your perspective, you cross the event horizon and continue your journey inward, but to someone watching from a safe distance, you would appear to slow down as you approach the horizon. Your image would get dimmer and redder, a phenomenon called gravitational redshift. As the light struggles against the immense gravity, they would see you frozen in time at the edge for eternity, never actually crossing. You, however, would be long gone. So what awaits at the very end? The singularity. A point where all the mass of the black hole is crushed into an infinitely small, infinitely dense point. Here, our current understanding of physics, both general relativity and quantum mechanics, completely breaks down. We simply don't have the tools to describe what happens there. It is the ultimate unknown, a place where the universe keeps its deepest secrets. Falling into a black hole is a one-way journey into mystery. It's fascinating, final, and a profound reminder that some cosmic questions may forever lie beyond our reach.